My final project ideation. For this project, I'm going to build an object detection benchmark for interpretable AI models in autonomous vehicles. So the focus is on assessing two models, YOLO v3 and faster RCAN, and applying these XAI techniques such as shape, line, and sequencing maps. The goal is to determine how well these models explain their predictions and to measure both performance and interpretability across the entire Kitty 2D image dataset. So the motivation behind this project is that nowadays the autonomous vehicles are super popular, and it relies heavily on object detection systems to recognize and react to pedestrians, traffic signs, vehicles, and other road elements. There is growing concerns over the safety and transparency of AI-driven systems, so it is crucial to develop reliable benchmark to evaluate the accuracy and interpretability of object detection models. Current research in XAI offers techniques that can provide insights into the decision-making process of these models. However, the interpretability of these models under real-world driving conditions has yet to be rigorously evaluated. So this project seeks to address this gap by focusing on object detection within the context of autonomous driving. So the data I'm going to use for this project is the Kitty Vision Benchmark Suite. So the Kitty dataset is a widely used benchmark in the field of autonomous driving. The dataset contains high-resolution images captured from urban driving scenarios and includes annotations for object detection tasks, such as identifying cars, pedestrians, and cyclists. The model I'm going to use are YOLO v3 and faster RCAN. The YOLO v3 model is a fast real-time object detection model that predicts both object bounding boxes and class labels simultaneously. It uses a single neural network to predict multiple bounding boxes per image, making it highly efficient. And the faster RCAN is a two-stage object detection model. It first identifies regions of interest in the image, and then it classifies objects within those regions. It is known for high accuracy in detecting and localizing objects. I will be using three XAI techniques in these projects. The first one is shape, which uses game theory to calculate the contribution of each feature to the model's prediction. It assigns shapely values to each feature to quantify their importance. The second technique is line. It perturbs the input image by masking or altering parts of it and observe how the model's prediction change. It builds an interpretive model to approximate the behavior of the black box model. And the last technique is called sequencing map, which highlights the regions of the image that the model focuses on the most during its prediction. They are based on the gradients of the model's output with respect to the input image, showing where the model's attention was concentrated. And I'm going to quickly go over the evaluation metrics I'm going to use. I'm going to use both the performance metrics, which includes precision, recall, F1 score, accuracy, and MAP, as well as the interpretability metrics. The first interpretability metrics I'm going to use is fidelity, which measures how accurately the explanation reflects the true decision-making process of the model. The second metrics I'm going to use is completeness, which measures how many features are required to explain the model's decision fully. And here we can see is a sample benchmark result table I create. The columns include dataset, model, XAI techniques, and all the evaluation metrics I have just mentioned. I will have two models and three XAI techniques applied to each of them using the Kitty dataset. And for the experiments, I'm going to first perform the data preprocessing using the Kitty 2D image dataset. And then I'm going to use do model training and testing by first fine-tuning the YOLO v3 and the faster RCAN model on the Kitty dataset. And then I will train both model and evaluate performance on the test set using all the performance metrics. And then I'm going to apply the three XAI applications to each model's prediction to generate explanations for the detected objects. And lastly, I will do the interpretability evaluation by using the fidelity and completeness scores. I will using those evaluations to complete the benchmark table, and then I will summarize findings in a manuscript or poster that includes visualizations from shape, line, and sequencing maps, along with performance and interpretability results. So this is my final project ideation. Thank you so much for listening.